Hello, this is the Universal Mind Channel. It's part 6 of our series on how reincarnation works, I believe, and what physiological processes in the human body cooperate to get it done. I think I have discovered how it works. And I didn't do it by some religious enlightenment. Okay? It's not a religious process. Reincarnation, rebirth as the Asian philosophers call it, is not a religious event. No. It's a natural phenomenon. It follows natural laws just like any other physical and natural phenomenon. So let's take it out of the realm of religiosity and all that smoke and mirrors. Let's create a scientific-based term for this process so that we don't see it anymore as something that is part of the illusion of heaven and hell that people trying to convince others that heaven and hell exist just to control masses of people. It's easy to control them with fear if you create the illusion of a hell. It's easy to control people looking for heaven. But the Hubble and the Webb telescopes have looked back to the beginning, the dawn of time, the beginning of this universe. And neither one has found any evidence of a heaven or a hell. You know why? They don't exist. Except in the imagination of individual men. And back in time and throughout time, it's always been men that wanted to dominate the rest of the world. Not women. It's been men. Too much testosterone. Not enough wisdom. Not enough humility. Too much ego. Not enough compassion. Whatever heaven and hell is, it's been created in the minds of men. And we're the ones that create it, either heaven or hell, by what we do to ourselves and to each other. And the sooner we realize that, the sooner Earth becomes a safer place. So let's give reincarnation the name it deserves. Let's call it a scientific-based name. And for that, let's go to the Greek alphabet. Throughout time, throughout much of history, medical and scientific terms have been based upon the Greek alphabet. So let's call this PhiAlpha. If PhiAlpha exists, it does so not as a mystical force independent of physical laws of nature or the universe, but as a child in a process of universal laws and processes dependent upon them. PhiAlpha would obey the laws of natural selection and fitness for heritability and survival, just as any other process evolution creates. Because PhiAlpha would arise from and out of our own physical bodies, it would obey the same laws of thermodynamics and quantum mechanics and classical mechanics as any other physical state would and does. We cannot expect PhiAlpha to shout out its existence and say, "Come here, look at me. This is what it is. This is how it happens." PhiAlpha is like many other natural phenomena. It hides in plain sight. We just have to know how to look for it. To find PhiAlpha, we must search for its fingerprints upon the common, ordinary physiological processes we take for granted every day. We need to know what to look for. To do this, we must hypothesize, we must conjecture, think. What biological functions PhiAlpha would need to accomplish its task of preserving individuality, preserving memories, preserving information from a dying body to a body about to be born. And are there physiological processes, including quantum mechanical processes, that facilitate the transfer of biological information in the form of neural contained memories, biochemically stored, and transfer it from a dying body into one about to be born, a fetus. We must look within the human body to see if there is any evidence of such processes. If those processes exist, we can deduce PhiAlpha's existence, even if we're presently unable to observe its behavior. So, what's the purpose of PhiAlpha? What is it meant to accomplish? We understand that evolution employs group fitness and natural selection with the individuality of single mutations to create a counterbalance of spiraling complexity in organisms. We also understand that evolution has selected Homo sapiens as a species to be separated from the herd of all the other species for special attention. Why? This special attention includes maximizing complexity of cognition, language, and memory. All the things that are needed to create personality, individuality, in a coherent form, and to create ever more complex expressions of that individuality. That's what we call enlightenment. Individuality has not only become the most important trait evolution has created for humans, human history has shown that individuality has become an end unto itself. Therefore, the purpose of PhiAlpha must be the continuation of coherent individuality stored within neural encoded memories, biochemically. I think we can understand PhiAlpha more easily, or easier, by differentiating its component processes. What are the specific processes that PhiAlpha would need to operate? Let's think. Well, there would have to be an on switch, wouldn't there? So let's call that PhiAlpha activation. And then let's jump ahead a little bit. What would the next process be once it's activated? Organizing memories within the brain. Which ones do we transfer to an unborn fetus? Which ones do we select? We got to organize them, which means they have to be prioritized. So memory prioritization. Which ones do we need to preserve our individuality and which ones don't we need? Then we have to have some way of seeing to it that they are preserved in this process as the body's dying. Memory encoding. And then we have to transfer the memories out of the body. Memory emission. And then the last step. As those memories quantum mechanically transfer from the dying physical body to a fetus, memory reception. The fetus somehow must have the ability to absorb those biomechanical memories as they're transferred quantum mechanically from the dying body into itself. How does it do that? Does the fetus have a means by which to absorb that energy? I believe it does. I believe I've found it. And we're going to discuss it as we go forward. Let's take a look at the first step, PhiAlpha activation. PhiAlpha cannot be on all the time. Otherwise, its system requirements would dominate all the other physiological systems, and it'd prohibit normal life function. PhiAlpha must therefore lie dormant during normal life events and require a specific genetic upregulating stimulus or event for expression. What does that mean? Specific genetic upregulating stimulus or event for expression. Well, genetic upregulating, that's just a scientific term for activating a gene. Genes are dormant, genes can be alive, but when they activate, they are upregulated. How do we know genes can lie dormant? Well, in prior episodes we've discussed how researchers have discovered genes activating in a dying animal up to 48 hours after the animal is supposed to be dead. Why does that happen? We don't know. But it does, for some reason. It doesn't happen for no reason. It doesn't happen for no reason. Those genes are turning on, upregulating for a specific reason. But the animal's dead. No, obviously not. Because if the gene is activating, the body's not dead. Something's going on that we don't understand. And again, you know why? Because religious intolerance has pressured scientists not to look into this stuff. And it's time that changed. Because we're entering a new era. And we either have to, like every other species, come up to speed very quickly on this. PhiAlpha cannot become active every time we catch a cold or the flu. If that were the case, our bodies wouldn't be able to function. Even abnormal events such as a broken bone or disease will not or should not. And I don't think it's possible to initiate PhiAlpha with just a broken bone. If that were to happen, too much chaos within the body, too much going on in the body wouldn't be able to survive that. While serious, each of these conditions are survivable with proper medical care, and I don't believe PhiAlpha is triggered with just what evolution sees as normal routine injuries or illnesses. Something significant has to happen within the body for PhiAlpha to be triggered. PhiAlpha activation must require an extraordinary life-threatening event. Further, PhiAlpha cannot be a simple one-step or even a two-step process. If this were the case, our minor illnesses and routine accidents would cause PhiAlpha to rev up too easily and too soon. If it's just a one-process startup, just a fever might activate PhiAlpha. The activation of PhiAlpha would require physiological processes to happen which would take away the energy within our bodies and prevent our bodies from healing naturally and normally. That can't happen. That'd be self-destructive. Evolution doesn't allow that. The added physical stress of PhiAlpha's startup would only exacerbate otherwise routine illnesses and injuries. To guard against premature PhiAlpha startup, evolution would need to create a specific set of conditions, a trigger. Plus, evolution would have to create a biological structure that was created to moderate, control the process once it started. Therefore, PhiAlpha would need to distinguish between a life-threatening but reversible crisis and the beginning of the death process itself. There has to be a line upon which, when the body recognizes that line crossed, that has to be a trigger. Evolution has created, I believe, the perfect mechanism to serve as such a trigger and also a monitor. The brain's limbic system. It's perfect. The limbic system is located in the most secure area of the brain, at the brain core, near the brain stem itself. It's the last part of the brain that would die, be devoid of oxygen during the death process. So it would be the last part of the brain to be operating. But what does the limbic system do? Well, overall, the limbic system appears crescent-shaped, similar to that of the human ear. The limbic system is composed of an intricate arrangement of many brain organs. We'll discuss in a minute. While the size of those organs may be small when compared to the rest of the brain, their functions and interactions are extremely complex. The limbic system is critical to our theoretical model because it's the command and control center for all PhiAlpha processes in the dying body. We'll shortly see that the limbic system's control over essential body functions, consciousness, emotions, and memories will have a direct impact upon PhiAlpha's critical functions. But let's go to what makes up the limbic system. The amygdala, the cingulate gyrus, the corpus callosum, the fornix, the hippocampus, the hypothalamus, the indusium griseum, the septal nuclei, and the stria terminalis. Those 9 organs make up the limbic system. Let's start with the hippocampus. The hippocampus processes new memories for long-term storage and regulates the mind's sense of present awareness. Protruding out of the amygdala is the stria terminalis, which carries nerve impulses to and from the septal nuclei, hypothalamic, and thalamic areas of the brain. It's believed to serve as the means of implanting fear and anxiety impulses upon memories. So as an event happens, it's that area of the brain that says, we're afraid, fear. The cingulate gyrus sits just above the corpus callosum. Like many of the other organs of the limbic system, the cingulate gyrus is crescent-shaped and surrounds the other organs of the limbic system. It looks almost like a helmet, and it sits atop the other organs of the limbic system just like a helmet would, a head. The corpus callosum is a thick crescent-shaped band of nerves connecting the left and right hemispheres of the brain. That's critical because it connects the 2 hemispheres in the brain. The corpus callosum is the largest nerve bundle in the brain, containing between 200 million and 250 million axons. The corpus callosum possesses the largest amount of white matter in the brain, and it's located between the cingulate gyrus and the fornix. Now, the fornix is a crescent-shaped nerve bundle that serves as the main output channel for the hippocampus. It also carries nerve fibers to the hippocampus from the forebrain. Like the rest of the organs of the limbic system, the fornix is known to play an important role in how specific emotions are bonded upon our memories. Like the rest of the organs of the limbic system, not a lot is known about what the other functions of the fornix may be. The human hypothalamus is located at the base of the brain, near the pituitary gland. About the size of an almond, the hypothalamus is positioned almost in the exact center of the skull. It's believed to control or moderate a large number of brain functions, including pituitary gland function, hormonal release, circadian rhythm, body temperature, and behavior. The hypothalamus is highly reactive to light, olfactory stimuli, smelling, steroids, neurally transmitted signals from the heart, and other major body organs, blood-borne stimuli, infectious agents, microorganisms, and stress. The indusium griseum is a thin layer of gray brain matter covering the upper surface of the corpus callosum. It contains 4 longitudinal bundles, 2 on each side. Again, not much is known about its function. Its location suggests it plays an important role in the limbic system's emotional memory organization. The septal nuclei are a set of structures made up of both lateral and medial component. Bulbous in shape, they are located below the corpus callosum and are connected to the olfactory bulb, hippocampus, amygdala, hypothalamus, midbrain, cingulate gyrus, and thalamus. They are believed to play a role in pleasure responses, but the literature indicates an almost complete lack of understanding of its functioning. Now, The information you've just read comes from sources that are referenced and cited in the book Reincarnation and Scientific Theory. They'll also be cited. Most of these references come from just because they're so basic. I just went to Wikipedia, but I will list them in the information attached to this video. The thalamus is a knob-shaped structure of gray matter with twin lobes located in the center of the brain. While not considered by current medical science to be part of the limbic system, its extensive array of nerve connections to the hippocampus suggests otherwise. It also has connections with the cerebral cortex and is believed to play a significant role in consciousness and states of sleep and wakefulness. The thalamus acts as a relay station, sorting, processing, directing signals traveling between the spinal cord and the rest of the body. It must be emphasized that as much as modern science has advanced in the last 50 to 100 years, it's yet to unlock the many mysteries within the brain and the limbic system. While it's understood that the limbic system plays a critical role in how our emotions are imprinted upon our memories of specific events, the scope and specific other functions of the limbic system and the individual organs themselves remain largely unknown. It's a simple fact that with every single piece of knowledge we gain about the brain, every bit we learn raises ever more questions. For example, while researchers have known for some time the brain possesses both electrical and magnetic fields, they have only just begun to study how to validate and calibrate electrical current flow in computer models with the results taken from living human test subjects. Cerebral spinal fluid, we've discussed before, is an excellent source of both electric field and magnetic field activity in the human brain and the human body. The reason for this is that cerebral spinal fluid contains many elements that, when dissolved, become electrolytes such as sodium, potassium, magnesium, chloride, phosphate, and bicarbonate. Cerebral spinal fluid also carries salt water and trace elements, including copper, zinc, aluminum, and iron, all of which serve as what? Excellent conductors of electricity and electrons. We call the electromagnetic field generated by cerebral spinal fluid flow the neural net. This neural net is a biomachine created by the pulsing action of the cerebral spinal fluid flow, creating what is essentially an organic computer. In other words, there's a pump. The pulse rate within the body pushes cerebral spinal fluid around the brain. It's a pulse. The brain is engulfed in bathed in cerebral spinal fluid the way our bodies are bathed in photons. Photons aren't liquid. The cerebral spinal fluid is. But we're bathed by both. That cerebral spinal fluid comes from up the spinal cord, through the back of the head, and washes around the brain in a bath. And it creates both an electric and a magnetic field. And there's a flow of electrons, and there's a flow of photons being constantly emitted from the brain, from every brain, as a result of that pulsing action. There's a motor. Some would say it'd be the same as a computer. We believe one of the functions of this cerebral spinal fluid and this flow is PhiAlpha. The brain's PhiAlpha program is activated upon a significant crisis threatening our lives, regardless of the proximate cause of our death. The initial point at which our body becomes aware of the possibility of death is called the stress response, and that begins in the amygdala, that almond-shaped mass of interconnected neurons located deep in the brain's medial temporal lobe. The amygdala moderates our reactions to events that we define as critical to survival. The amygdala controls our reactions to all sorts of major events in our lives, from signaling the presence of food to warning of predators and rivals, the selection of mates to the instinctive responses to the threat of danger to children in similar crisis situations. Any event the senses perceive as a credible threat to survival triggers an immediate response from the amygdala. It's instantaneous, and it's beyond our control. It's evolution in action. Natural selection, survival. The amygdala's neurons may serve as the memory store necessary to confirm or reject the sensory stimuli alleging the threat. Is it a threat or not a threat? The amygdala tells us whether it is or it isn't a threat. A threat to our survival. In other words, the neural memories contained within the amygdala may serve to either verify the stimuli as a valid threat or not, depending upon how the new threat matches with memories of past experiences. Certainly, to function properly as the brain's early warning center for life-threatening events, memories contained in the amygdala would have to be very long-term memories indeed. Upon validating the true crisis, the amygdala sends a signal to the hypothalamus. The hypothalamus is also almond-shaped and is located near the amygdala in the brain's most protected core area, next to the pituitary gland, just above the brainstem. The hypothalamus acts as the central processing unit of the body's autonomic involuntary nervous system. It maintains the body's internal chemical and electrical balance, and it also controls such functions as heart rate, blood pressure, body temperature, fluid and electrolyte balance, appetite, body weight, glandular secretions of the stomach and intestines, sleep cycles via the release of hormones. All of that. Basically life. There are few, if any, threats to the life of the body that are not detected by the hypothalamus. All these functions occur without our conscious awareness. They're unconscious, but they exist. Both amygdala and hypothalamus work together to instantly respond to crises before our brain's vision center is able to cognitively identify the event as a threat, before our conscious brain can perceive by sight and react to it. The amygdala and hypothalamus has already begun the threat response. Now I'm going to give you a little flow chart here. This is what I believe happens when such an event occurs. It illustrates the physiological event cascade that results from the detection of any possible threat by the amygdala and hypothalamus. 1. Signal from the amygdala to the hypothalamus, threat. Then the signal from the hypothalamus to the involuntary nervous system. Then the signal from the involuntary nervous system to the sympathetic nervous system. And then from the sympathetic nervous system to the autonomic nervous system and the adrenal gland. The adrenal gland creates and releases adrenaline, epinephrine, to respond to the threat, to make the human body more aware. Adrenaline release causes physiological changes, increased heart rate and blood pressure. Senses become significantly more focused. And then adrenaline is exhausted, causing hypothalamus to activate secondary hypothalamus and the pituitary and adrenal glands' HPA axis threat response. When adrenaline becomes exhausted, in other words, you're under threat. Let's say you're in a car wreck and you're pinned in the car and you're trying to get out. Adrenaline activates immediately to give you heightened strength because you're panicked, you're fear. And this is an immediate fear response, adrenaline. But at some point, that adrenaline, it's a drug. And it's and you're getting inoculated, but it's from within. And that adrenaline hits you. You respond accordingly, but if you're not released, it has a time frame within which after which it's out of juice, It's exhausted. Then what happens? Once the adrenaline's exhausted, it causes the hypothalamus to activate a secondary response. The HPA axis signals the release of a corticotropic hormone, CRH, into the pituitary gland, which then triggers the release of adrenocorticotropic hormone, ACTH, that travels to the adrenal glands and initiates the release of the last-ditch defense for your body and your brain, your awareness. Cortisol. C-O-R-T-I-S-O-L. Cortisol. Cortisol is the body's last line of defense against a life-threatening event. A complex hormone released only after the initial release of adrenaline has become exhausted. Cortisol is the body's final biochemical stimulus to enhance performance to counter any perceived life-threatening event. Cortisol release initiates a series of physiological changes to help us survive. Some changes are easily understood. However, the purpose of several other changes created by cortisol remain mysterious. For example, cortisol upregulates, turns on 3 genes: interleukin 4, interleukin 10, interleukin 13. These genes help the body reduce the severity of injury by increasing anti-inflammatory and antibody production. As a diuretic, cortisol increases water excretion through perspiration and renal plasma flow from the kidneys. These are just a few of the many effects of cortisol. Remember, cortisol is released only in a severe crisis situation. You've already exhausted adrenaline, and you haven't been able to save yourself yet. You're still at risk of death. However, cortisol also increases sodium retention by causing the sodium-potassium ion pump to go into overdrive. When death seems imminent, the cortisol forces increased retention of sodium ions at the same time as it's trying to increase water excretion. Sodium atoms retain water. These processes are in opposition to each other. They conflict. What's happening? What is so important about the cellular sodium-potassium ion pump that forces cortisol into causing 2 opposing physiological processes during a time when one would logically expect all physical processes to be joined together in an active effort to survive? Before we can answer this question, we must first discuss cortisol's other effects. Cortisol has 2 other effects upon the body in crisis that are significant to our understanding of PhiAlpha. Remember PhiAlpha? This is all about how PhiAlpha starts. Cortisol stimulates the release of copper enzymes, including lysyl oxidase and elastin. While copper enzymes maintain and repair connective tissue that may be damaged during the crisis, copper is also what? A perfect electrical conductor. By release of copper enzymes throughout the body, cortisol may be preparing the brain's neural net for PhiAlpha. This would also explain the sudden and seemingly contradictory retention of sodium ions in the neural cells. Sodium ions are also an excellent electrical conductor. PhiAlpha relies upon the body's electrical and electromagnetic fields to encode memories upon phased biophotons as they're released from cells within the brain. In other words, it may be that cortisol is the body's way to do 2 things. You're at a point, you're at crisis, or adrenaline hasn't saved you. So, cortisol is released, and it has 2 hands. One hand gives your body extra power, the last-ditch effort to survive. And yet the other hand creates the trigger that in case the saving hand, the survival hand fails, PhiAlpha begins. That's the only explanation for why this critical human function has conflicting purposes or conflicting results. This would explain the sudden and seemingly contradictory retention of sodium ions in the neural cells, because those sodium ions are an excellent electrical conductor. Lastly, during an extreme physical crisis, cortisol causes the brain to create what have become known as flashbulb memories of the crisis event. We suspect these crisis memories are given this flashbulb physiological emphasis to hasten their routing to the amygdala and encoding into PhiAlpha if the crisis becomes fatal, or preserved for future reference in the amygdala's long-term memory storage. In other words, if you survive this event, cortisol release after adrenaline exhaustion, if you can survive this, this is an event you better not repeat. So there's a heavy imprint, a heavy emotional biochemical imprint upon neurons that are being created as like a film, like a video tape of this event. Flashbulb memories also contribute to the creation of PhiAlpha. Because what is PhiAlpha? But encoded memories, sealed quantum mechanically for transfer out of a dying body into a fetus. We conclude that it is this release of cortisol that triggers activation of PhiAlpha in the brain. Makes sense. Being at the heart of the body's central processing unit, the limbic system is perfectly designed to monitor the crisis and modulate the expression of PhiAlpha accordingly. In the event the body is mortally wounded, the limbic system has already set in motion those functions necessary for PhiAlpha to take over. If the crisis is somehow averted, however, the limbic system discontinues cortisol release. PhiAlpha shuts down, without the individual ever being aware it existed. That's how PhiAlpha begins. The next step is memory organization within the dying body. And we'll get into that in the next episode of Reincarnation, the Scientific Theory, here on the Universal Mind Channel. You can contact us if you have questions or comments at the Universal Mind Channel at theuniversalmindchannel.com at the Universal Mind Channel at gmail.com. That's the Universal Mind Channel at gmail.com. Finally got it right. Have a good day, and we'll see you next time. Take care.